All right, so chapter 5. Deals with sequences. And so question 5-1 says, George and Lenny start a rabbit farm. So they start with 2 rabbits. And each pair of rabbits births, I guess we'll call it, 2 rabbits each month. So the question they ask, how many rabbits do they have in a year? Okay, so what I want you to do is take a few minutes, okay, and try to identify, okay, any which way you want, okay, how many rabbits they're gonna have after 12 months. You can try drawing a picture, you can try making a graph, you can try making a table, you can try anything your heart desires, okay, but see if you can figure that out. So I'll cut a couple different things. Okay, I'm going to try and draw a picture just to give us an idea and then kind of make a table off of that. So we have our first 2 rabbits right here. Okay, those are our starting ones. So make a table to go along with it so I can kind of keep track. So after 0 months, we have 2. It's one short. Okay, so after that first month, like I said, each pair has another pair. So after 1 month, that pair gives birth to numbers 3 and 4. So after 1 month, there's a total of 4. Next month, that original pair has another pair, as does the new pair. So 5, 6, 7, and 8. All right, next month, each pair has another pair, so we get 9, 10, 11, 12, 13, 14, 15, and 16. Okay, and if you were drawing a picture, this is probably where you started to give up because it starts to get pretty crowded. Okay, but we end up having 17, 18, 19 and 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, and 31 and 32. So if I take a look at my graph, I can start to recognize the pattern, right? We went from 2 to 4 to 8, 16, 32. What's happening each time? It's just doubling. Okay, so instead of trying to keep drawing my picture, I can just kind of pick up on the pattern. Okay, this would give me 64, 128, 256, 512, 1028, 2056, 4092, and in month 12, they would have a total of 8,192 rabbits, which is obviously a lot. Okay, it's also taken in the assumption that, well, none of the rabbits are dying in that process. Two, pretty much kind of have to have a boy and a girl each time. Okay, so this would be how you recognize that. So notice that the big difference is that instead of adding between each term, now we are multiplying between each term. So if we take a look at 5-3, okay, it gives you a couple other cases. So case 2, start with 10. You have 2 babies a month. Case 3, start with 2, and they have 4 babies a month. And in case 4, start with 2 and 6 babies a month. Okay, so I want you to find out how many they have after 5 months. Okay, so in those 3 instances, find out how many babies they'll have after 5 months. All right, so on the first one, month 0, okay, we have 10. Okay, if we have 2 babies a month, it means we're essentially the same as above, where we're multiplying by 2 each time. So month 0, we have 10. Next month, we'd have 20. Then we'd go 40, 80, 160, and 320. Case 3, we start with 0. Sorry, start with 2 in month 0. Okay, and if they have 4 babies a month, okay, so you can kind of draw a picture, but they would have 3, 4, 5, and 6. Okay, and then the next month, each pair would have another 4. So they would have 2 there, 2 there, 2 there. So we'd go from, let's see, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Which kind of helps us identify the pattern. Growing by 3 each time. So then the next month we'd have 54. We'd have 162. And then month 5, we'd have 486. Okay, case 4, we start with 2. Okay, and we're going to have 6 each month. So again, we can try and draw a picture, but we have 1, 2. And we have 3, 4, 5, 6, 7, 8. And then we have 6 more. So 1, 2, or 3, 4, 5, 6. All right, which is a lot. I could count it up, or you could just take my word for it that it should be 32. And then 128, 512, and 2048. Okay, so it helps to draw a picture. Okay, just to kind of give you an idea, I'm sure some of you just said, oh, I'll just multiply by 4 each time, or I'll just multiply by 6 each time. Okay. Okay, but the big thing to take away is that, okay, a lot of the stuff in this chapter, okay, is being able to identify how we are going from one term to the next, whether it's adding, or now in this case, we could also be multiplying. Okay. Questions on that? Okay, so another big thing from this chapter okay, is our what we call a rebound ratio. Okay, the way we find that is we take our rebound height We divide it by our starting height. Okay, we'll get into some details here in a second. Okay, do whatever you got to do to really emphasize this. Okay, but your rebound ratio represents your rebound height divided by your starting height. Okay, this is a large percentage of what this chapter is. Okay, so question 518 asks about the bounciness or the rebound ratio of certain athletic balls here. So say a tennis ball dropped from 200 centimeters bounces up to 111 centimeters. So our rebound ratio, again, our rebound height in this case would be 111. The starting height was 200. So it has a rebound ratio of 0.555. Okay, so that basically means for every unit it is dropped, it needs to bounce up 0.555 of that. Okay, soccer ball needs to be dropped from 200 centimeters again up to 120 centimeters. So determining the rebound ratio, okay, 120 divided by 200 gives it a rebound ratio of just 0.6. Okay, basketball. Dropped from 72 inches, needs to bounce up to 53.5. Okay, just because it's in inches, it doesn't really change anything. Okay, you're still just taking your rebound height, dividing by your starting height. So 53.5 divided by 72 gives us a rebound ratio of 0.743. Okay, and the last one is a squash ball. Don't know what a squash ball is. You'll be just fine in life. But drop from 100 inches up to 29.5. Means a squash ball has a rebound ratio of 0.295. Okay, so the closer the rebound ratio is to 1, the bouncier it is. Okay, because it's essentially the closer it bounces up to its original height. Okay, so of those 4, which one is considered the bounciest? Which one's closer to 1? Should be the basketball. Okay, which one's the least bouncy? Squash ball, right? It's furthest away from 1. So we're going to build a lot more on these. In the future, okay, but it's important to kind of identify how to determine the rebound ratio. Okay, basically what we'll ask you in the long term is if a basketball is dropped from 100 feet and bounces up to, 74 feet, how high is it going to bounce on the 5th bounce or something like that. So that's kind of where we're heading with this, but we have to be able to at least find the rebound ratio first. All right.